Alright everyone, I'm picking up right here on number 5. So for number 5, it's going to be similar to these problems for number 4, except we have a bit more complicated exponent here. So you can see that it's x minus 3, but we still have a variable as an exponent, so we're going to do the same thing we did here for these problems up on top. So the first thing we want to do is take the log of both sides. And then we want to bring the exponent down, so it's going to be x minus 3 and multiply it times the log of 5.825, and the last thing we want to do is divide by log of 5.825 on both sides. So we're going to end up with x minus 3 equals log of 120 divided by log of 5.825. So before we continue here, let's divide log of 20 or 120, I'm sorry, by log of 5.825, and that gives us 2.71. So 2.71, so we have x minus 3 equals 2.717. So now the last thing to do here is we want to add 3 to both sides. So when we add 3 to both sides, we'll end up getting x is approximately equal to 5.717. Okay, so that's your answer right there. And I believe that's it. So the next one, now right here you want to reverse the order of operations when you're solving for x, and that's what we're going to end up doing here. So the first thing you want to do is you want to divide by 18. So right here you want to divide by 18 first, and we're going to be left over with 1.2 to the 2x minus 1 equals 50. So when you divide 900 by 18, you get 50. Now we want to go ahead and take the log of both sides, and when we do that, afterwards we're going to bring the exponent down. So I'm going to skip a step here and write it as 2x minus 1 log of 1.2 equals log of 50. And then we're going to divide both sides by log of 1.2, so we'll end up with 2x minus 1 equals log of 50 over log of 1.2. And when we get that answer, let's see, log of 50 divided by log of 1.2 is 21.458. So let me continue this over here. So 2x, let me see, right over here. So 2x minus 1 is approximately equal to 21.457. Now here, next we want to add 1 to both sides. So we'll get 22.457. And lastly, we want to divide by 2. So x is approximately equal to 11.228. So that's our final answer right here, 11.228. Alright, now for number 6, you want to change these into exponential form. So notice that we have a logarithm. It's not that easy to think about this logarithm, so we want to change it to exponential form. So this, we want to take 25, raise it to the x power, and make it equal to 5. So this is the equivalent of 25 to the x equals 5. And now, in order to get 5, we have to raise 25 to the 1/2 power. So then x has to be 1/2 or 0.5, however you want to write it. Now same thing for this one. We can rewrite this one as x to the 0 equals 1, and any number to the 0 equals 1, so x is going to be any real number. So that's how you would write it. Okay, so that's the solution for that one, any real number. This one, same thing. we can rewrite it as exponential form. So 10 to the 23rd power equals x. So if we raise 10 to the 23rd power in your calculator, it's going to display it in scientific form. So it's going to say 1 times 10 to the 23rd. So either way would be fine. I mean, this could be your answer as well, 10 to the 23rd power. Or 1 times 10 to the 23rd. So that's what you had to do for number 6. Now number 7, for these problems, you have to factor out each of the numerator and denominator. So the top right here, if we do the diamond problem, 6 would be our product and 5 would be our sum. So we're gonna find the two numbers, and those are 3 and 2. So the top right here is gonna factor out to 3x plus 2 and x plus 3. And the bottom, whenever you have an x squared and an x term, then it's easier to factor. You just look to see what you can pull out from each of these. So right here we can pull out an x from here and factor out an x from here. So we're going to be left with x times x minus 4 times, I'm going to expand this right here, so I'm just going to write it as 4 times x. So 4 times x, and the bottom x plus 2, it's just going to stay as x plus 2. But I'm going to put parentheses around it so that you can see that as a whole, this is being multiplied to the rest. So now we can cancel out x plus 2, we can cancel out the x and cancel out the x. So in the end, this problem ends up as x plus 3 times 4, and notice that the 4 is still here, so we're multiplying it to that, over x minus 4. And this would be your answer. We can't simplify it any further than that, and we've already multiplied it. So that's the answer for that problem. Now number 8, notice we have a similar situation up here. So we have an x squared term and an x term. We can factor out an x from each of those. So we're going to write it as x times x minus 2 over. Now the bottom one, we're going to have to factor it using, let's try using the diamond problem, see if that helps us factor it. So for this one, I'm going to say 4 and negative 4. So the two numbers are negative 2 and negative 2. So it would be x minus 2 times x minus 2. Now here we're dividing, so I'm going to rewrite this as multiplication of the reciprocal of the second one. So I'm going to write x minus 2 as the numerator and 4x squared as the denominator. But 4x squared, I'm going to expand it, and I'm going to write it as 4 times x times x. That way I can see what can cancel out. So notice that 4 times x is the same thing as 4x squared. Now here I see that this is going to cancel out, this is going to cancel out, and these two, and then an x and an x. So we're just left over with 1 over 4x. Okay, and that's your answer. Number 9, this is what we call the difference of squares. So the difference means that we're subtracting, and of squares means that the first part can be obtained from squaring, and the second number can be obtained from squaring. So right here we can rewrite this as x plus 4 times x minus 4. That's always going to be similar in how you factor those. So anytime you have the difference of squares, you can easily factor it. It'll always be x plus something and x minus something, depending on what you have on the first one and the second one. So then the bottom one, I'm just going to write it as x minus 4 times x minus 4. And this is being multiplied, so the top here, let me try and factor that out. So it's negative 18 and negative 3. So for this one, it's going to be negative 6 and 3. And that'll give me x plus 3, x minus 6 over. This one I'm going to use the same thing, so factor it out. So this one's going to be negative negative 6 and 4. Give me negative 24 when I multiply them, and negative 2 when I add them. And that works out, so it's going to be x plus 4, x minus 6. So now we can see that we have this one and this one cancel out, x minus 4 and x minus 4, and x minus 6 and x minus 6. So we are just left over with x plus 3 over x minus 4. That's your answer. Alright, Now let's go to this one. For these, you're trying to add or subtract, and let me check my time. We are down to 10 minutes. I'll have 2 more minutes. So for these, we want to add or subtract. So you want to have the same denominator. But right here, we see that we don't have the same denominator. We want to have the same denominator before we can add these fractions. So in order to do that, notice that this one is 4 times x minus 7. So I'm going to multiply this one times 4 over 4. So if I multiply by 4 over 4, I'm going to end up with 20 over 4 times x minus 7. And the other fraction is going to be 3 over 4 x minus 7. I just left that one the same. And now I can add these two fractions because I have a common denominator. So this would end up being 23 over 4 times x minus 7. And I can't really simplify this any further, so I'm just going to leave it like this. Alright. You don't have to multiply the 4 times this x and the negative 7 because they're not asking us to expand or do anything like that. So we can leave it like this. Number 11, same thing. Right here we can see that we don't have a common denominator, but let me try and factor this. So notice that we have the difference of squares again, just like we did up here, x squared minus 16. So I'm going to rewrite this. So I have 2 over x plus 4 minus x minus 4 over, now this factors out to x plus 4 and x minus 4. Now notice that within this fraction we're multiplying. I can cancel out these two.
Palatino, please come to the main office. Brian Palatino, please come to the main office.
Alright, so now what I did here is I canceled out these on the right fraction, and I can do that because these are being multiplied. Alright, and I can go ahead and cancel. So I'm left over with 1 over x plus 4. And now you can see that we have the same common denominator, so now I can go ahead and subtract. So this is going to equal 1 over x plus 4. And that's your final answer. Remember that when you subtract fractions, the denominator doesn't really get subtracted, only the numerator. Okay, so that's why I left the denominator as x plus 4. We only affect the numerator. The last one is going to be, well, you know what? Let me stop right here, and I'll continue on the next part.